Ramanujan for G is now available on the Google Play Store. Try it out for free.
Good morning, class. So in the maxima and the minima today, we will start with the greatest and the least value of function in a given interval. Okay, so let's start. Greatest and least values of a function in a given interval. Okay, so like if a function fx is defined in an interval a to b, then greatest or the least values of this function occurs either at x equals to a or x equals to b, or those values of x where f dash x is equals to 0, right? So remember that the maximum value of function fx in an interval a to b is not necessary that it's the greatest value in the interval. So like greatest value of fx in interval ab is equals to max f of a, f of b, and f of c, and least value of fx in interval ab, so it will be minimum of fa, fb, and fc. Okay, so where x equals to c is a point such that f dash c is equals to 0. Okay, so quick copy this, then we will take one example. Okay, so like question to find the greatest value of x cubed minus 12x square plus 45x in interval 0 to 7. Okay, so let fx is equal to x cubed minus 12x square plus 45x. Okay. So f dash x will be 3x square minus 24x plus 45. Okay, so it will be 3 of x minus 3 and x minus 5. So f double dash x is equal to 6x minus 24. So now for maximum and minimum values, So this is 3 of x minus 3 and x minus of 5, which is equals to 0. So x is equals to 3 and 5. So again, we can say like f of double dash 3 is minus 6, which is less than 0. So the function is maximum if at x equals to 3, and similarly if f double dash 5 is equals to 0, which is equals to 6, which is greater than 0, then the function is minimum at x equals to 5. So now f0 is equals to 0, f3 is 54, and f5 will become 50, and similarly f7 is 70, right? So the greatest value in the function is from 0 to 7. So max is 0, 54, 50, and 70, which is 70. So this is the answer. Now there's one more question. The maximum value of x cube minus 3x in interval 0 to 2 is, okay. So let fx is equals to x cube minus 3x, right? So then f dash x, which is 3x square minus 3. So for maximum or minimum, f dash x is equals to 0. F dash x is equals to 0. So which is x is equals to plus minus 1. But x is equals to minus 1, which is not belongs to 0 to 2. So therefore, x is equals to 1 only. Okay, so we can easily check that f dash x is greater than 0, means we can let x dash f dash x is greater than 0 uh, for x equal to 1. So fx range local minimum at x equals to 1, local minimum, right? So f0 is 0, f1 is equals to minus 2, and f2 is equal to 6. So fx attains its maximum at x is equals to 2. So this is the answer. Okay, so next thing is the properties of maxima and minima. Okay, so like first property, if fx is continuous function in its domain, then at least one maxima and one minimum must lie between two equals value of x. Okay. Second, maxima and minima occur alternately. Okay, so this is between two maxima, there's one minimum and vice versa. Similarly, if fx is maximum or minimum at a point x equals to a, at a point is x is equals to a, then 1 by fx, which is fx is not equals to 0, will be a minimum, will be minimum or maximum at a point, at that point. Okay, next, if fx is as infinity as a, as extends to a, and f dash x is equals to 0 only for one value of x, let's say it be c, and between a and b, then fc is minimum and least value. Similarly, like if fx tends to infinity as x tends to infinite, and fc is the maximum and the greatest value. Okay, so fc is max and greatest value. Okay, so there are so these are the few properties of maxima and minima. So while solving question, we must remember this. So it will help a lot. So our next topic is maxima of two variable. Okay, so like if a function is defined in terms of two variables, and if these are associated with the given relation, then by eliminating one variable, we convert function and then by eliminating, we convert function in terms of one variable and then find the maxima and the minima by known methods. Okay, so let's take one example. Maybe there was some network issues, so previous recordings are not there. So let me take it to the screen recording. So this was the first slide. This was the question based on this greatest and the least integer. There was one more question to find the max. Again, we have the max value of x cube minus 3x in the interval 0 to 2. And this was the properties of maxima and minima. Now, here we are discussing maxima and minima of a function of two variable. So if x plus y is equals to 8, x plus y then find max value of xy. So solving, let z is equals to xy. So z is equals to x8 minus x, or we can say z is become 8 is equals to minus x square, right? So dz by dx is equals to 8 minus 2x, which is equals to 0. So x is equals to 4. So d square z by dx square is equals to minus 2, which is less than 0. So we can say x equals to 4 is maximum point. So maximum value z is equals to 8 into 4 into 4 square minus of 4 square. So it will be 16. Next, we have to divide 64 into two parts such that the sum of the cubes of two parts is minimum. Okay, so like x plus y is equals to 64. So y is equals to x cube y cube, which is equals to x cube plus of 64 minus x of whole cube. So here x cube plus 64 minus x whole cube. So dy by dx will be 3 x square minus 64 minus x whole square is equals to 0, right? So we can say 3 of 2x minus 64 into 64 is equals to 0. So x is equals to 32. So d square y by dx square is equals to positive. So hence it's a minimum. Okay. Now there are some standard geometrical results. Okay. Some standard geometrical results. Okay. So the following results can be there. So like first, the area of rectangle with a given parameter is the greatest when it's a square. The perimeter of rectangle with the given area is least when it's a square. And the greatest rectangle inscribed in a circle is a square. The greatest triangle inscribed in a circle is equilateral. The semi-vertical angle cone with a slant height and maximum volume is tan inverse root 2. Similarly, the height of cylinder of a maximum volume inscribed in a sphere of radius is 2a by root of 3. Okay, so these are some standard results. Okay, now we will write few of these. So like first is equilateral triangle. So area is equals to root 3 by 4 x square, where x is side. Okay, second square. So area is equals to a square, and perimeter is 4a. Third rectangle, area is equals to ab, perimeter is equals to 2a plus b. Okay, like next is trapezium. So area is equals to half of A plus B H. Okay. So now we will look at some problems. So question is given the maximum area of rectangle of perimeter 176 centimeter is. So let sides be let sides of rectangles be x and y. Okay. So 2x plus 2y is equals to 176. So for maximum, its area is a. So which we can write xy. So which is x of 88 minus of x. So 88x minus x square. So dA by dx is equals to 88 minus 2x d square a d square x is equals to minus 2 less than 0. So now dA by dx is equals to 0. So x is equals to 44. So then d square a by dx square is also less than 0. So area will be maximum where area will be maximum when x is equals to 44. So maximum area will be 44 into 44, which will be 1936 square units. Okay, so this is the first problem. So copied. Now the next question. Like if the sum of the length of hypotenuse and another sides of right angle triangle is given, so that the area of triangle is max and angle between these is. So like let it be a triangle. Okay, A, B, and C. So this is given theta, this is x, and this is k minus of x. Right? So we will solve. So AB plus AC is equals to k. So AB is equals to x, then AC is equals to k minus x. So BC square will be k minus x square minus x square. So which will be k square minus 2k r. Right? So area of triangle will be half of BC into AB. Right? So it will be half into under root of k square minus 2k x. So let z is equals to delta square, which is 1/4 x square and k square minus 2k x. So finally it will be 1/4 of k square x square minus 2k x cube. Right? So z is equals to max when x is equals to k by third. So cos theta is equals to uh, x divided by k minus x. So it will be k by 3 and k of k minus k by 3, which is equals to half. So theta is equals to pi by 3. Okay. So next problem, a running track or 440, it's said to be laid out enclosing a football field, the shape of which is a rectangle with a semicircle at each end. If the area of rectangle portion is maximum, then the length of its sides are okay. So asking for length of its side. Okay. This is pi r. Let it be b a d c. This is x side. This is again x, and this is pi r. Okay. So perimeter is equals to 440 feet. So 2x plus pi r plus pi r is equals to 440. So 2x plus 2 pi r is equals to 440, right? So A is the area of rectangle portion, which is equals to x into 2r. So A will become x for this is 2x by pi, which is divided by 1 by pi of 440x minus 2x square. So dA by dt is dA by dx, sorry, dA by dx is 1 by pi 440 minus 4x. So it will be x is equals to 110. So d square A or dx square is equals to negative, right? So we can say here like 2r is equals to 440 minus 2x divided by pi. So it will be 440 minus 220 by 27 by pi by 7. So solving it will be 70. So 70. So this is our answer. Okay. So 110 and 70 both are required answer. Okay. So thank you guys.